Well, we're concerned about new technology and all kinds of things that are going into vehicles that distract them from focusing on the primary task of driving. And so we're trying to assess the usability of these devices to provide manufacturers feedback on how to make them better. And we're also trying to develop ways to predict when these devices will be distracting. Obviously, we'd like to develop methods to assess the devices that exist, and we're focusing on methods that are much faster and cheaper to do than the methods that industry uses now. We're trying to help them use those methods to design products at the outset that are safer to use, and we're trying to build kind of more general theories and models that will predict when distraction will occur. Oh, I'd say there are clearly ways that we can reduce distraction. I think the first thing, though, is just to develop better ways to calculate when distraction will occur. So what we've been working on are calculation methods to say, step by step, what does a person need to do? They need to push this button. They need to think about this. They need to make the following kinds of decisions. And then for us to have predictions of the times and number of glances and other performance measures required for each step, you simply put those numbers in a spreadsheet and add them up. The big advantage is you can literally have what the industry calls a wireframe, a paper and pencil sketch of the structure of the interface. And you have that 6 months to a year before you're ever going to have working hardware and software. And furthermore, the advantage is because it's just on paper, you can change it easily. If you see something that takes too long or requires too many eye glances, you change it. And then the consequence is that what you actually end up producing, even before you ever get to subject testing, is much better.